So lesson 4.3 is on derivatives of inverse trig functions. So before we get into the trig function part, we're going to quickly review what the inverse of a function is. So the inverse is when the x and the y switch places. So if I had y equals 2x, the inverse then would be x equals 2y. So the x and the y switch places, and then when I want to get the y by itself, now we can see that y is equal to x over 2. So the inverse means we're going to flip. In function notation, if g of x is the inverse of f of x, then what this is saying is basically when my x value is 2, my y value is 8, so the inverse, they would flip. My y becomes my x, and my x becomes my y. So you could see a problem that looks like this example. It says that f and g are inverses of each other, and it gives us all these values. It gives us f of 1 is 3, f of 3 is 6, the derivative of f of 1 is 2, and the derivative of f of 3 is 3. Now what they're asking for, though, is what is the value of the derivative of 3. So if I look here, this is my formula for the derivative of g of x, and what it's equal to is 1 over the derivative of f of g of x. So basically what that means is we have to use inverse to kind of work backwards. So I know that our x value we are working with is 3. So I know that I am looking for g of 3. The problem, though, is there aren't any g's up here. But if we remember, this is saying my x is 3, we don't know my y. Well, this is g. That means f has some inverse where that 3 is actually the y value. So that we can work with, because up here we have all the values. So if I look right here, that tells me that when x is 1, the y is 3. So that means here, the inverse, the x is 3, the y is 1. So that means g of 3 is 1. So now I can rewrite this as 1 over the derivative, and now I know my x value is 1. Now this one is in the table. Let me erase this. That tells me that when the derivative f of 1 equals 2, so that means my answer is 1 over 2. So the derivative of g of 3 is equal to 1/2. So let's try that again. Now it says f is this function. F of x is negative x cubed minus x. G is going to be the inverse again, and they want to know what is the derivative of g of 10. So same thing, we're going to go to our formula here, and I have to find this inner part. I want to know g of 10 equals what y value. So that means I have a 10, and I have my missing y. Now what that tells us is the inverse then, we're going to have f of something equals 10. So what we're going to do is we're going to go up into this equation, negative x cubed minus x, and we're going to set it equal to 10. And we're going to see what x value will give us that 10. So first thing to make life easier, let's go ahead and pull out a negative x. and that'll give us an x squared plus 1 equals 10. And now we have to figure out, well, what value of x here will help us get to 10? And this is where it's going to be some guess and check. So what I'm going to do is I'm going to think about, well, I know my 10, since there's two factors here, I know to get to 10, it's either going to be 1 and 10 or 2 and 5. And if I look here, I don't think 1 and 10 is going to work because that's going to give us too big of a number. So if I try plugging in a 2, that gives us negative 2 times 2 squared plus 1 equals 10. 2 squared is 4. 4 plus 1 is 5, times the 2 will give us our 10. Now the only problem here is that technically gives us a negative 10, and we want it positive, so what happens if we try a negative 2? If we try a negative 2, that's going to give us negative 2 squared, that still gives us our 5, and over here a negative negative would make that positive. So that means our x value here is when x is negative 2, f of x will equal 10. So that means when we flip it, when x is 10, g of x will be negative 2. So now I can write g of x equals 1 over the derivative of f of x when x is negative 2. Now pay attention because this says derivative. So that means we need to actually find the derivative of f of x. So the derivative of negative x cubed is negative 3x squared. And then minus 1. So now we're going to find what the derivative of f of x is when x equals 2. Sorry, negative 2. So negative 2 squared is 4. 4 times negative 3 is negative 12. Minus the 1 gives us negative 13. So our answer here would be g of 10 equals 1 over negative 13. So that would be our answer. So that was just to get you thinking of inverses. Now we are going to actually get into trig identities and inverses. So one of the things that you're going to have to use in this whole lesson are these trig identities that you would have learned in Algebra 2 or pre-calculus. So these are just identities that you really need to have memorized by the AP test. So we have sine squared x plus cosine squared x equals 1, tangent squared x plus 1 equals secant square x, and 1 plus cotangent squared x equals cosecant squared x. And what we're going to have to be able to do with these is you're going to need to be able to rewrite them. So what I mean by rewrite them is we won't be working with sine squared x. Instead, you're going to want to know that sine x is equal to the square root of 1 minus cosine square x. So I subtracted to move it over and I square rooted it. Same thing with cosine. Cosine x equals the square root of 1 minus sine squared x. And then you may have to manipulate these other two also. So these are really important. Make sure you have them written down so you can reference them during the whole lesson. So here is our problem. We have if f of x equals the inverse sine of x cubed. They want to know what is the derivative of this. So the steps that I'm using are going to be kind of long, but you'll get the hang of it after a while. If you watch the videos on the program, they use a different method, but I feel more comfortable just following these steps. If you want to see the other method, feel free to watch the videos online. So basically what we're going to have to do as we're doing this is we are going to follow these steps. So first thing we're going to do is I'm going to write my problem. We're going to have y equals the inverse sine of x cubed. Then what we're going to do is we're going to switch the x and the y. So that ends up giving us sine y equals x cubed. So make sure that when we do the inverse and they flip, this no longer is an inverse, it's just sine y. Now we're going to do our implicit differentiation from the last section. So the derivative of sine is cosine. So we'll put cosine y dy dx to show that that's implicit differentiation equals, the derivative there is 3x squared. Now we need to get our derivative dy dx by itself. So that's going to become dy dx equals 3x squared over cosine y. Now here's where those trig identities from the last page are going to come into play. Right now, our problem has both x's and y's in it, and we need to rewrite it so that it's only in terms of x. So what I'm going to do, since I have cosine y, I'm going to look and I see that cosine is the same thing as the square root of this. So I am going to substitute, and it's going to become 3x squared over the square root of 1 minus sine squared y in the square root. Now we know what you're thinking. I said our goal was to get an x and an x, and I still have an x and a y. Well, the identities don't let us change it directly. But now what it's let us do is, if you notice, this is a y, and this up here also tells us y equals. So now what we're going to do is we're going to substitute in that y. And this is where things are going to look kind of crazy, but you're going to learn a shortcut pretty soon. So that's going to give us dy dx equals 3x squared over the square root of 1 minus sine squared, and now instead of the y, we're going to write the inverse sine of x cubed. So this looks really bizarre, but there's something that I want you to keep in mind. Way back when, you learned that a function and its inverse always multiply to make 1. So if I have x times its inverse 1 over x, that means they cancel out to equal just 1. Well, the same thing works with sine and inverse sine. If I multiply them, like what it's showing right here, they basically cancel each other out and make 1. And then the sine squared, that just means that whatever this function is, it needs to be squared. So what we can do is, I know that the sine and the sine cancel out to make 1. So what that's going to give us is dy over dx equals 3x squared over the square root of 1 minus, and now those cancel out, so you're left with an x cubed squared. So all I did was I took this squared, I moved it to the x cubed, and then the signs canceled out. So that means our final answer is dy dx equals 3x squared over the square root of 1 minus x to the 6th. So where I said you'll learn shortcuts after a while is you're going to quickly learn that when you substitute right here that y, you know that the signs are going to cancel out, and you're just going to be left with whatever is in here is going to be written as that squared. So once you start getting the hang of it, you don't have to write. So in this problem, we're doing the same steps, but now we're going to be working with tangent. So first thing we're going to do is I'll write it with the y. So y equals inverse tangent 2 over x. For the differentiation, it's okay if you want to use it as 2x to the negative 1. Perfectly fine. Now we're going to write the inverse. So tan y equals 2x to the negative 1. So when we differentiate, the derivative of tangent is secant squared y dy dx equals negative 2 x to the negative 2. Now we'll get that by itself. So dy dx equals negative 2x to the negative 2 over secant squared y. Now if you remember from the identities page, secant squared x is the same as tangent squared x plus 1. So we're going to substitute so that we can get our tangents to match. So that gives us dy dx equals negative 2x to the negative 2 over tangent squared x, oops, sorry, it's still a y, plus 1. And now this is where we're going to substitute, and I'm going to go ahead and use the original version. So that gives us dy dx equals negative 2x to the negative 2 over tangent squared times inverse tangent of 2 over x. Make sure I have enough parentheses there. Plus 1. Now we know that this and this will cancel out. So we will have dy dx equals negative 2x to the negative 2 over 2 over x squared plus 1. So that's going to give us negative 2x to the negative 2 over 4 over x plus 1. Now comes the problem where we have all sorts of fractions everywhere. So what I'm going to do is I'm going to write it dy dx equals negative 2 over x squared divided by 4 plus x all over x. And the reason why I did that is because this is 4x plus 1, and we need them both to have the common denominator. So basically, I changed it into x over x, so it still equals 1. Now we have to remember that division is the reciprocal of multiplication. So negative 2 over x squared times x over x plus 4. So now that gives us negative 2x over x squared, x plus 4. I can cancel out the x here, the x here. So that's going to give us negative 2 over x squared plus 4. This one, same thing. We'll go with tangent y equals 1/2 x. Just pulled the 2 out. The derivative of that is secant squared y dy dx equals 1/2. So that gives us dy over dx equals 1/2 over secant squared y. Go ahead and rewrite that. Dy dx equals 1/2 over tangent squared y plus 1. Now this time I'm going to go ahead and use a shortcut because I know automatically that the tangent inverse and the tangent will cancel. So that's going to give us dy dx equals 1/2 over x plus 2 squared plus 1. So that gives us 1/2 over x squared over 4 plus x. And now, just like the last one, we need common denominators. So we're going to make this 1/2 over x squared plus 1. X squared plus 4 over 4. And now we can do it quicker. The 4 goes to the top. That 2 goes down to the bottom. And that gives us 4 over 2 x squared plus 4. And now we can cancel. So we get our answers 2 over x squared plus 4. So once you get the hang of it, it actually starts going pretty fast. You just have to be pretty comfortable with your exponent rules and your division. So let me know if you need any help as you start working on the problems.